Mathematics crossing your eyes? Maybe Pocket Ronnie can help you.
Okay, we're going to be doing half-angle identities, and here is, so this first problem we're looking at 12b2, we're looking at sine. So half-angle identity for sine, the formula looks like this. Sine of b over 2, and b represents the angle, okay? Actually, we're going to call it not b, beta. So that represents the angle. So, and that equals the square root of 1 minus cosine of beta all over 2. Now for every formula, there is a plus or minus in front of the radical, because we always put plus or minus in front of the radical. That plus or minus tells you this positive or negative is dictated by what quadrant you're in. Remember, so sine, everything is positive, quadrant 1. So this positive or negative is dictated by what quadrant you're in, essentially. Whatever angle this is, what quadrant you are in. So this is the reason it's called half angle, is because you're taking an angle and then divided it by 2. Half angle identity. So over here we're wanting to do sine of 15 degrees. Well, in order for, if we want to turn this into a half angle, then our beta needs to be double this amount. In other words, what I'm trying to say is sine of 15 degrees is the same thing as saying sine of 30 degrees divided by 2. Because 30 degrees divided by 2 is 15 degrees. So this 30 has now become our beta. So we're going to use this formula, and everywhere we see beta, we're replacing it with 30 degrees. So in other words, if we have sine of 30 degrees divided by 2, and also the instructions say to evaluate, so we're trying to find an answer, and the instructions also say we can use our calculator. So even though 30 degrees is a special angle, we're actually going to use our calculator and get decimal values for these trig values. So sine of 30 degrees divided by 2, I'm going to use this half angle identity formula, and 30 degrees is in quadrant 1, so everything is positive in quadrant 1. So I would use the positive sign in front of my radical. 1 minus cosine, and instead of beta, I'm replacing it with 30 degrees. So cosine of 30 degrees divided by 2. So essentially, this is sine of 15 degrees. 30 degrees divided by 2, 15 degrees. And instead of using our fraction forms or radical forms, we're going to put everything into a decimal. And remember, when we do trig values in decimal, you're doing it to 4 decimal places. So cosine of 30 degrees is 0.8660, because I'm doing it to 4 decimal places, divided by 2. Okay, just double checking. Okay, then 1 minus that, 1 minus 0.8660, that is 0.134, then divide that by 2, and then that would be the square root, so 0.134 divided by 2 is 0.067. Now take the square root of that, and sine of 15 degrees is 0.2588. Yes, we could actually stick this straight into our calculator, sine of 15 degrees, and I get the same answer that I do there. But what we have to think about is, this is in the days they did this, they used these half angle identities before this little invention was made. And so that's why they have all these trig identities. They use this before having little computers in our hand. And so this was the way that they could calculate an angle from something else that they knew. So here we're just practicing using these identities. Okay, so now we're going to go to 12C4. We're still doing a half angle identity. This says the instructions say to evaluate using a half angle identity and using your calculator. In other words, we're going to be putting everything into decimals, not using the fraction value. So the first thing you have to know is the formula for half angle identity for tangent. So for tangent, you actually have, there are 3 different formulas for half angle identity for tangent. So I'm actually just going to use one of them. So if I have tangent of some angle divided by 2, I'm actually going to use this one. There are 3 different formulas you could use and they'll all come out with the same answer. So, well, I'm just going to go ahead and write them all down. So you have 1 minus cosine beta all over 1 plus cosine of beta, or you can use, and remember this plus or minus is dictated by what quadrant you're in, plus or minus 1 minus cosine beta all over sine beta, or you have sine beta all over 1 plus cosine beta. Okay, just know that these 2 do not have a radical. This one does. Okay, so this one has a radical in it. These 2 formulas don't. So I'm just going to end up using this one. So I need something I need 3.75. So I'm going to have some angle, tangent of some angle divided by 2 is the same as 3.75. So essentially I need to double this. If you double 3.75, you get 7.5 degrees. If you took 7.5 divided by 2, you end up with 3.75. Okay? So we're going to do tangent of 7.5 degrees divided by 2. So tangent of 7.5 degrees divided by 2, and all this does is just gives us practice using these formulas, these half angle identity formulas. Okay, I'm going to use this formula right here. So 7.5 degrees is my beta, and which is 7.5 divided by 2 is 3.75. I'm in quadrant 1, everything is positive in quadrant 1. So choosing my plus or minus, I'm using my positive because I'm in quadrant 1. 1 minus cosine of beta, and here beta is 7.5 degrees, all divided by sine of beta, and in this case my beta is 7.5 degrees. So this is where we get to use our calculator. 1 minus, and then cosine of 7.5 is 0.9914, taking that to 4 decimal places. And then sine of 7.5 is 0.1305. So 1 minus that, 0.0086 divided by 0.1305. That equals 0.0659, and that should be tangent of 3.75 degrees. And you should be able to check this into your calculator. You should be able to put in 3.75 degrees, hit your tangent button, and you're going to get pretty close to the same thing. When I just put it in my calculator, 3.75 degrees, I got 0.0655. You can see we're off on the 4th decimal place. This is due to rounding. When I rounded to my decimal places earlier in the problem, this is off due to rounding. And that's okay. Okay, now looking at 12B10, the instructions say to verify or prove. So basically when you're verifying, you are proving that the left side equals the right side. Okay, and if you notice, this is actually a half angle identity formula for cosine. Cosine half angle identity looks like this: 1 plus cosine of beta divided by 2. So So they're just having you go through these motions to prove that this is true. And basically what I talked about in the last two problems. So cosine of 36 degrees divided by 2. You're doing this first. You're doing 36 divided by 2 first, not cosine of 36 degrees and getting a decimal, then dividing by 2. You are taking the angle and dividing by 2 first, so essentially that would be cosine of 18 degrees is this, 1 plus cosine of 36 degrees divided by 2. Okay, now that's square root of everything. Now let's get our decimals for all these trig functions. Cosine of 18 degrees. That is 0.9511 equals the square root of 1 plus cosine of 36 degrees. 0.8090 all divided by 2. So we're trying to prove that the left side is equal to the right side. We're proving that these half-angle identities truly work. So that would be 1.8090 divided by 2. Then take the square root of that. So if I took this divided by 2, okay, that would be, the next step would be 0.9511 equals square root of 0.9045. Then take the square root of that. 0.9511 is equal to 0.95105, which rounds out to that. So basically what we did is we proved that this does really equal that these half-angle identities truly do work.